So welcome back. So we are discussing about different components of the universe. The first component is nebula, second component is galaxies, third component is stars, and fourth component is star system, right? So we have completed discussion on nebula and even galaxies. Now we have to discuss about stars, right? Already we have started the discussion on the stars. So star meaning it's a luminous object that emits its own light and heat, that we call the star. And there are billion of stars in the universe. And here the very important point, there are billion of stars in the universe, but the star which is very close to us is sun. That is a very important point. Just listen. So here stars, so there are billion of stars in the universe. There are billion of stars in the universe. There are billion of stars in the universe. But the star which is close to us, there are billion of stars in the universe. But the star which is close to us is known as sun. But the star which is close to us is sun. You can write down sun. The star which is close to us is the sun, right? Okay, very important. So there are billion of stars in the universe, but the star which is close to us, it is the sun, right? Very important point. For example, so here sun and earth, right? Sun and earth, the distance between the sun and earth, the distance is 150 million kilometers. So distance between sun and earth is 150 million kilometers. 150, nothing but 150 into 10 to the power of 6 kilometers, right? 150 million kilometers, or 150 into 10 to the power of 6 kilometers. And this distance we call one astronomical unit. One astronomical unit, very important. So you call 1 AU. 1 AU meaning one astronomical unit. This is a distance between the sun and earth. And your light, listen carefully. So your light it reaches the earth surface in 8 minutes and 20 seconds. So light reaches the earth surface in 8 minutes and 20 seconds. And light travels with speed 3 into 10 to the power of 8 meter per second. So 3 into 10 to the power of 8 meter per second, or it can be written as 3 into 10 to the power of 5 into 10 to the power of 3 meter per second, right? So here, so 3 into 10 to the power of 5, that we call 3 lakhs. 10 to the power of 3 meter, so we call kilometer per second. So 3 lakhs kilometer per second, very important, 3 lakhs kilometer per second. So distance 150 million kilometers, light travels with speed 3 into 10 to the power of 8 meter per second, or 3 lakhs kilometer per second. And light takes 8 minutes and 20 seconds to reach the earth's surface. Very important point. So your sun is very close to earth, and the distance between the sun and earth is one astronomical unit. That is a very important point. Next one. So your star system, and one more important point, just listen. So your sun is closest star to us, and the second closest star to us is Proxima Centauri. Next point, second point, Proxima Centauri is second closest star to us. Second closest star to us. Very important. Proxima Centauri is second closest star to us. So Sun is closest and Proxima Centauri is second closest star to us. Very important point. Next one. So here star system meaning, listen. So star system meaning a group of a star and its celestial bodies all together we call star system. For example, suppose your sun is the star and it having 8 planets, that is Mercury, Venus, this is Mercury, right, and Venus, and even Earth, Mars, Jupiter, Saturn, Neptune, Uranus and Neptune, right, Neptune. So these are the planets. So your sun, that is star at the center, and planets, asteroids, comets, all together we call star system. So if you get the question, how many star systems are there in the universe or in the world? So answer is again billion. There are many star systems, but among all star systems, so solar system is one, or we call sun star system. Just listen, sun's star system. Sun star system, so we call the solar system. Our solar system is also known as sun star system. So like that, there are many star systems in the universe. So don't think only we are having one solar, like we are having only the sun star system. So like sun star system, there are many star systems, right? Very important point. So star system, there are billion of star systems in the universe, but amongst star systems, sun star system is also one, right? Next point. So here now we'll discuss this life cycle of stars. Very important. This also is very important topic. Life cycle of stars. So the way everyone having the life cycle meaning the duration between the birth and death, we call the life cycle. So the way we are having the life cycle, even the water also having the life cycle, that we call hydrological cycle. Some minerals also having the cycle, that we call mineral cycle, hydrological cycle, like that. It's a star cycle. So star cycle meaning it's a continuation or repetition of the life. Origin and repetition, repetition. That repetition we call the life cycle, right? So life cycle of stars is very important point. If you get the question, so how the stars originates, so from where the star originates, then question is nebula. So nebula is the source or origin. So here nebula consists hydrogen and helium and even particulate matter. It consists particulate matter, right? And this nebula splits into small pieces, and that leads to formation of stars, right? So star, if you get the question, so how the star form? The star will form from the nebula. So nebula splits into different pieces, right? And that leads to formation of star. And the star will end its life in any one of the following 3 forms. Star will end its life in any one of the following 3 forms. First form is white dwarf. So second form, listen. So second form is neutron star. Second one is neutron star. And third one is black hole. Right? You remember? So the star originates from nebula. What is nebula? Nebula is the cloud of 2 major gases, hydrogen and helium, and particulate matter, that we call nebula. Nebula leads to formation of star, right? It's a origin of stars. Origin of stars. So star originates from nebula and it ends its life. It ends its life in any one of the following three forms: white dwarf or neutron star or black hole. Now we'll discuss one by one what is white dwarf, what is neutron star, or what is black hole, right? So first put the heading white dwarf, or you should know which star ends its life as a white dwarf, right? Or which star ends its life as a neutron star, or which star ends its life as a black hole, right? So first one is white dwarf. White dwarf, right? So first write down the meaning to call or the criteria to call as a white dwarf, right? So just listen. If mass of a star, is less than or equal to 1.44 times the mass of sun. If mass of a star is less than or equal to 1.44 times the mass of sun, then it is known as white dwarf. And it is known as white dwarf. Then it is known as white dwarf, right? So here, if mass of a star so is less than or equal to 1.44 times, this is very important, 1.44 times the mass of sun, then it is known as white dwarf. So that is mass of white dwarf is less than or equal to 1.44 times the mass of sun. This equation is very important, right? So your mass of white dwarf should be less than or equal to 1.44 times the mass of sun, and then only we call as a white dwarf. To call white dwarf, the criteria or the condition is mass of this white dwarf should be less than or equal to mass of sun. Then only we call it a white dwarf. For example, just consider so mass of sun is 100 kg. Just I am assuming, right? The mass of sun is very huge, but just I am assuming, just for your easy understanding. If suppose mass of sun is 100 kg, then to call as white dwarf, the mass of white dwarf should be less than or equal to 1.44 into this mass of sun is 100 kg, right? So here less than or equal to 144 kg. So mass of white dwarf will be less than or equal to 144 kg. If mass of any star, you take any star, if its mass is less than 1.44 times the mass of sun, then we call as a white dwarf. Just example, if mass of sun 100 kg, then to call as a white dwarf, its mass should be less than 144 kg or equal to 144 kg. For example, this is one more interesting point. If suppose mass of white dwarf, it can be equal to 144 kg, or mass of white dwarf, it can be 140 kg, or mass of white dwarf, it can be 100 kg, or mass of white dwarf, it can be 80 kg, because here the equation is less than or equal to 144 kg, right? So your mass of white dwarf can be 144 kg, meaning white dwarf can be greater than sun, right? In this case, because mass of sun is 100 kg and mass of white dwarf is 144 kg. So white dwarf is more than sun here in this case, and here also white dwarf is greater than sun, and in this case mass of sun is 100 kg, mass of white dwarf is also 100 kg. So here white dwarf will be equal to sun, right? And in this case mass of white dwarf is 80 kg and mass of sun is 100 kg. So here white dwarf will be smaller than sun. So it's meaning white dwarf, listen carefully, it's very important point, and very important point and very interesting point also. So here white dwarf can be greater than sun, or white dwarf can be equal to sun, or white dwarf can be smaller than sun. Very important point. So white dwarf can be, just write this point. So white dwarf can be greater than sun, or equal to the size of sun, or smaller than the size of sun. Very important, smaller than the size of sun. So here white dwarf can be greater than sun, or equal to the size of sun, or smaller than the size of sun. Very important, right? So in this case white dwarf is greater than sun, in this case white dwarf is equal to sun, in this case white dwarf will be lesser than the sun. If you get the question what is white dwarf, the first answer, white dwarf meaning any star that having mass less than or equal to 1.44 times the mass of the sun is known as white dwarf. So if you get the question white dwarf can be greater than sun, yes, true, white dwarf can be greater than the sun. So white dwarf can be less than sun, or white dwarf can be equal to sun. All the three statements are correct here. Very important point. So white dwarf. Next point, just listen. So your next point, this is about white dwarf, and next one is neutron star. Next one is neutron star. Next one is neutron star. So neutron star meaning, just start with first meaning of neutron star. If mass of a star is greater than 1.44 times and lesser than 3 times the mass of sun. If mass of a star is greater than 1.44 times and lesser than 3 times the mass of sun, then it is known as neutron star. To call neutron star, just see the condition here. That is, so your mass of neutron star should be greater than 1.44 times the mass of sun, and should be less than 3 times the mass of sun. So this is the equation for neutron star. Very important. So neutron star equation. So mass of the neutron star should be greater than 1.44 times the mass of sun, greater than 1.44 times the mass of the sun, and lesser than, this symbol shows lesser than, so 3 times, less than 3 times the mass of the sun, and greater than 1.44 times the mass of the sun. Such star we call neutron star. Very important. So neutron star, if you get the question, so can neutron star is smaller than sun? So answer is no. So neutron star never be lesser than sun, because the condition is so that it should be greater than at least 1.44 times the mass of the sun, but not less than sun. But here white dwarf can be less than, or it can be smaller than sun, but neutron star never be smaller than the sun. And this is the last year UPSC question. So last year they asked this question about the neutron star. So neutron star, so it it never be smaller than sun. Very important point. And second point, just listen. So here, suppose it's the neutron star, and this is the axis of the neutron star, and the neutron stars will rotate around its own axis, right? This is the axis of the neutron star, and the fast spinning or fast rotating neutron stars are known as pulsar. There is one important term called pulsar. So pulsar meaning the fast rotating or fast spinning neutron stars are known as pulsar. Very important. So pulsar meaning fast rotating or spinning. Fast rotating or spinning neutron star. So fast rotating or spinning neutron star is known as pulsar. And this question also asked in the exam. What is pulsar? So what is pulsar? Pulsar meaning a fast rotating or fast spinning neutron stars are known as pulsar. Very important. What is neutron star? The star which having mass 1.44 times greater than the mass of the sun and 3 times lesser than the mass of the sun is known as neutron star, right? Very important. And what is pulsar? A fast rotating or spinning neutron star is known as pulsar. So next we are having the third one, black hole. Third one is black hole. So whenever you listen to the term black hole, hole meaning is technically not a hole. So black hole meaning it's an area, very large area. So where gravity remains maximum, or the area which consists maximum gravity we call black hole. Just listen. So here first one condition to call black hole is if mass of a star, if mass of a star is greater than, if mass of a star is greater than 3 times the mass of sun. If mass of a star is greater than right. So if mass of listen. So if mass of a star is greater than, just 1 minute. Okay. So your mass of a star is greater than 3 times the mass of sun. Then we call as a black hole. So that is mass of black hole should be greater than at least 3 times the mass of sun. Very important point. Its meaning black hole never be smaller than the star or sun star. So black hole will be always larger than or greater than so the star. Very important. Sun star. So black hole will be larger than the star. Very important point. And the size of black hole will be at least 3 times greater than the size of the sun. It can be more than 3 times also. Sometimes the black hole can be 4 times larger than the sun, or 5 times larger than the sun, or sometimes 20 times larger than the sun. But it should not be lesser than, or it will not be lesser than the 3 times the mass of the sun. Very important point. So mass of black hole so will be greater than 3 times the mass of the sun. Very important point. And black hole, one more point about black hole. Black hole meaning, so it is an area. It is an area with huge gravity. It is an area with huge gravity. Very important. So it is an area with huge gravity. This, underline this word, huge gravity. So it is an area with huge gravity, right? Full stop. So even light also will not pass. Even light also will not pass from black holes. So black holes So black hole meaning it's an area with huge gravity, right? And so here this area consists huge gravity. Even light also will not pass from this area. Just imagine how much gravity that area might be having. So because when the light comes to that area, it attracts, it absorbs, but it will not allow the light to pass from that particular area, right? So it is an area with huge gravity. Even light also will not pass from black hole or from such areas. Very important. But next point. So this black hole is very much in the news. Black hole is very much in the news because so the black hole, they emits the waves that we call gravitational waves. The black hole emits the gravitational waves, right? So next topic is so here gravitational waves. So here gravitational waves. So here when two black holes, listen, when two black holes collides each other, for example, just listen. Suppose this is one black hole, it is another black hole. When these two black holes collides each other, so they emits heat, right? They emits heat, and that heat energy travels in the form of waves. So this energy travels in the form of waves, and such waves we call gravitational waves. Such waves are known as gravitational waves. Very important. Listen, if you get the question, what is gravitational waves? So when two large black holes collide each other, because of their collision, so heat energy will release, and that heat energy travels in the form of waves, and such waves we call gravitational waves, right? So gravitational waves, just write on one line, gravitational waves meaning, so when two black holes collides each other, when two black holes collides each other, so large quantity of energy will be released. So large quantity of energy will be released, which travels in the form of waves, are known as gravitational waves. Very important point. So here are known as gravitational waves. Very interesting and very important point also. Next point, just listen. And about these gravitational waves, it is clearly mentioned. So in Einstein's theory there is one theory called the theory of relativity, right? So theory of relativity, in the theory of relativity, so it is clearly mentioned, right? So here general theory of relativity is very important point, right? So this about gravitational waves, if you get the question, so in which theory about gravitational waves is mentioned, then answer is general theory of relativity, and this theory proposed by Einstein, very famous scientist Einstein, right? And in this theory it is very particularly mentioned that there is a gravitational waves, and the theory proposed in 1916. Very important point, just write down. So here about gravitational waves, about gravitational waves, it is mentioned in a general theory of relativity. Right? So it is clearly mentioned in the general theory of relativity. Very important point. It is clearly mentioned in the general theory of relativity. And this general theory of relativity, so it is proposed by a famous scientist Einstein, right? A famous scientist Einstein. So Einstein proposed this theory, that is general theory of relativity, in 1916. And in this theory, it is clearly mentioned that gravitational waves. And this theory says that when two black holes collides each other, right? So the energy releases, that energy travels in the form of waves, and that waves we call gravitational waves. And the first record of gravitational waves, it is mentioned which theory? The general theory of relativity. And this theory proposed by whom? Einstein. In which year? 1916, right? And to discover these gravitational waves, so a very beautiful and very wonderful project was launched by USA, and that project name is LIGO. That project name is LIGO. We famously call as the LIGO project, right? We famously call as the LIGO project, and already UPSC asked the question 2 times on this project. That is LIGO project. And what is LIGO project, and how this system works, and how many projects are there in this entire world, that we'll discuss in the next session, right? Thank you so much. Take care. Bye bye.